we are loading the object references. The same concept we followed here, right? Here one thing is there. Why I drawn like this means here one terminology available here. In first program, this bank customer, we call it as an outer class object. Bank customer is known as outer class object. Through this outer class object, we are referring some objects. So you can say referred objects, you can say. Means through bank customer, we are referring address object. Through bank customer, we are referring contact object. These two objects are known as referred objects, you can say. Here also say through RD, read details object, you can access book details. Through display details, you can access book details. So book details is known as a referred object. These two are outer class objects. So finally, references are categorized into two types. Make it. Types of references. Types of references. References are categorized into two types. Tightly coupled references, loosely coupled references. Tightly coupled references, and you can say loosely coupled references, you can say. Tightly coupled references and loosely coupled references. So tightly coupled reference means like this. The first case. The referred objects are available to only one object. The process in which referred objects are available to only one object, and these referred objects are created while outer class object creation is known as a tightly coupled reference. Means that object available to one object is called tightly coupled, available to one. Here, the process in which referred objects are available to more than one object, and in this process, referred objects are not created while we are creating objects for outer class objects. While we are creating objects for outer class objects, referred objects are not created. They are already created and available. Then they are coming and binding into these objects. So this concept we call it as loosely coupled references. You can say. So this is loosely coupled and this is tightly coupled. Make it. The process in which referred objects are available to only one outer class object. The process in which referred objects are available to only outer object, and these referred objects are created while we are creating objects for outer class. While we are creating outer class object. See that the process in which referred objects are available to only one outer class object, and these referred objects are created while we are creating outer is known as tightly coupled reference. Example: first program, the application references one. Loosely coupled reference, the process in which referred objects are available to more than one outer class object, and these referred class objects are not created. The process in which referred class objects are and these referred objects are not created while outer class object creation is known as loosely coupled reference. Example of study: application related references. is theoretical I given there. Yesterday, while creating object for bank customer, these two objects are created, and these two objects are available to only one object. So this tightly coupled with reference. Here, while creating objects for read details, display details, this referred object not created because already created. Not created, and the referred object are available to more than one object. It is loosely coupled. First one is tightly coupled, second one is loosely coupled. That is for interview purpose only. Moreover, this references other meanings as a relation. I made a statement already as a relation. So this is references. So references. Instead of interlinking objects, why don't you interlink the classes? Now we are trying to link objects here. Why don't we interlink the classes? Like a citing inheritance. Star mark inheritance in Java. The process of interlinking two classes with extension. The process of interlinking two classes with extensive keyword. The members of one class are available to another class. The process of interlinking two classes with extensive keyword and the members of one class are available to another class is known as inheritance process. Inheritance process. We are linking two classes with extensive keyword and we are making members of one class available to another class. The concept we call it as inheritance. This is yesterday's use. We are going to use somewhere these references. So many locations I am going to use it. Whenever I am using, I will explain and I will use it. Okay. So today's class. Instead of linking objects, we are linking classes. So this is one class now. I will take class A. I will take one class B. So A is one class and B is one class. We are going to link these two classes. Extends. Now here, variable will be there, method will be there, concept will be there, block will be there. This is common. The class now. Here also variable will be there, method will be there, constructor will be there, block will be there, and so on. Now, A members are available to B. So we keep the arrow downward. This is flow diagram. Yes? The members of A are available to B, but B are not available to A. A members are available to B. B members are not available to A. Because of this reason, author said inheritance the name given for parent-to-child relation. Relation is parent-to-child relation. We have a features of parent, but parent will not have features of child. We look like our parents. Our parents will not look like us. Means what? We take features from parent. Parent will not take features from child. The flow is in one side only, not in two sides. So other side is an inheritance. Biological terminology inheritance means taking features from parent. So the relation is parent to child relation. So this relation name is parent. So class A, you can call it as parent class, or you can say super class, or you can say base class. Any one terminology you can use it. If you say parent class, you must say here child class, you can say. If you say super class, you must say subclass, you must say. If you say base class, you must say as derived class, you must say. Write them to it. All of it right. So A to B, the relation is inheritance. So how to write this diagram in syntax form, programmatical syntax form, like this. The same thing if you write like this in syntax, class A, the class name is A, and class body. So this is parent class body. Means parent class members. Class B extends A. Means extended from A. That is the way of writing. This is child class body. It's a way of writing. Class A, class B. Class B extends A. If you create object for A, class A, only parent members will come. If you create object for B, both members will come, parent and child. With a specialty. In inheritance process, if you create object for child class, the object will hold all the members of the parent and the child. In inheritance process, if we create the object for child class, in inheritance process, if we create object for class, then the object will hold all the members of parent class and child class. In inheritance process, if we create an object for child class, then the object will hold all the members of parent class and child class. All of you understood this statement? In Java, you can link objects or you can link classes. You simplify and learn it. Don't be confused. Object-oriented programming means class object. Just only will do that. So as an object-oriented programmer, you know class, you know object individually by last week only. So this week what we started now, we started linking objects, we started linking classes. So linking objects we done yesterday. Now linking class. When you are linking a class now, one class member is available to another class. Means if there are A and B is there, if I say B extends from A, then A is parent, B is child. So A members will come to B, B members will not go to A. In that syntax, if I create object for A, only A members only will come. If I create object for B, both members will come. Okay, right? Now whether they are coming or not, let me capture one by one in this. So how we are going to work means is, there static, non-static and so on. Methods static, non-static, constructor non-static, block static, non-static. So the discussion happens in three cases. Make it case 1. Instance members of the parent class, or you can say super. This case 1. Case 2 discussion. Not 1 minute. Instance, not instance members. You written. Variables and methods from the parent class or super class. Constructors from the parent class or super class. Case 3. Blocks from the parent class or super class. The meaning of this statement is, if I announce variables whether they are available to child or not, we cross-check. Some constructors in the parent, they are executed for the child object or not, we check it. Belongs in the parent, what are its behaviors, we are going to check it. Like this, the discussion has been categorized into 3 types. We start one by one. So first, variables and methods from the parent class. All instance variables and methods from the parent class will get the memory within the child class object. All instance variables and methods from the parent class will get the memory within the child class object and can be accessed with child class object. Can be accessed with child class object. All static variables and methods of parent class are available to child class and can be accessed with child class name and can be accessed with the child class name and can be accessed with the child class name. Right. To explain these 2 paragraphs here, I'll take one program and diagram. We'll get the clarity. Okay, right. One example program. Same name I'll take. A and B I'll take. See that. I'm taking one project, application, inheritance one. I'm taking 2 packages. Packages P1. Package P2. I'm taking. Under P1, I'm taking one class. That is A and B. Under P2, same under P1 only, I'll take one class. That is class A and class B. Class A and class B. This B extends from A. The syntax. Now in A, I'll take two variables, public int sum A, public static int B. One instance variable, one static variable, because I must take variable method, both I must take. Right. Here public void sum m1. This is instance. Public again we go to static void m2. My intention, one instance variable in A, one static variable in A, one instance method in A, one static method. What is not there means consider block. That's separate discussion. Okay, right. Now I am printing from M1. System dot out dot print ln. So this is parent class. I'm taking P class instance method m1 output. It can print A and B. Instance method can access both A and B. The value A. The value A is equal to plus A. So system dot out dot print the value so parent class is static. Parent class is static. That is M2. Static cannot access instance. Yes or no? So this is minimum rules you know already. Okay, right? So this is class A folder. Two variables, two methods. One is static, one is non-static. Members available. Constructor block not available. You have to observe it because concept only take 3 days. Without a
only inheritance concept only take 3 days.
Because one number of other questions will come. This keyword, super keyword, this array, super array, method hiding, constructor chain, overriding, overloading, all will come here. So it takes 3 days time to write one concept. So you have to observe it. Small things you have to observe. Okay, this is A. Now B extends A means the meaning. What are the members available in A will come here while object creation. So B also will have their own members. Public int sum x I will take. Public static int y I will take. So public void. Here I will take display 1 I will take. Here I took M1, here I am taking display 1. So here also one static method. Static void display 2 I will take. So this is child class anyway. So this is not parent class, it's child class. Instance method.
X and Y. So it is static.
Parent class, this is child class, static. Static. Display. Here X, here Y. It cannot access instance only. So A class completed, B class completed. Okay. So because of this extensive keyword, all the members are A available to B. Okay. Now go for one class. A and B, two classes linked with one extensive keyword. Go for one. Yes, it is true. Because while typing, you should understand. Because of this way, I given 3 days time to practice packages. 3 days, 4 days I given. Because you have to observe that flavor, it will give you almost 3 days time. Will give. Almost 3, 4 applications will keep there. So that student has to know what I am creating, what I am opening, what I am clicking. Because all we are running from here on from today. Under P2, I am creating one new class. So this is demo inheritance 1. First program 1 inheritance. So import java.util. Only one class, no scanner. So here import p1.start. So scanner object I am creating. Scanner s is equal to new scanner of system dot in s dot close in the last. Create object for a na b na. Louder. You have to create object for b. Child class you have to create. Parent class object you must not create in inheritance. So b ob equal to new b. You can comment here. Sir, this is child class object. Means memory created for child. You are trying to create one memory for child, not for parent. Now, system dot out enter the value for a. Enter the value for a. You know, variable a belongs to parent. Yes or no? Variable a belongs to parent. What kind of variable a? Instance variable or static variable or instance variable? Instance variable you have to access with class name or object name or object. As object number. Understand now? So if parent class object not there, you have to access with what object now? Child class object. What is the child class object now? OB. So OB dot A is equal to s dot next. That is supposed to say that instance member of parent available within the child. Because you are accessing now, it is not available, error will come. Now enter the value for b. Is a static variable, instance variable, static variable of parent. So because of extensive keyword, that static member available to child also. So static member of parent can be accessed by the child class name. What is the child class name of b? Dot b equal to s dot next in. Now enter the value for x. Anyway, x is a instance variable belongs to child. Child class OB. OB dot x is equal to x dot next in. Enter the value for y. Y is the static variable belongs to child. Child name is b dot y is equal to s dot next in. Now call methods from the parent. Call the methods from the parent. In methods from the parent, m1 is there, m2 is there. m1 is instance method. Call with the object name. Parent not having object. Who is having object now? Child. So OP dot m1. So call the static method with the class name. So p dot m2. Then call the methods from the child now. OP dot display1. And here p dot display2. So successfully we observed that. What you observed here now? All instance variables and methods from the parent class will get the memory within the child class. Memory must be there unless you cannot access it. So we'll get the memory within the child class object and can be accessed with the child class object name. First paragraph. Second one, static members will not come to object. After 4 weeks that only. So all static variables and methods of parent class are available to child class and can be accessed with the child class name. The same thing like that. So run it, the answer will come. Enter the value for A, enter the value for B, enter the value for X, enter the value for Y, the answer will come. So parent class instance method M1, parent class static method M2, child class instance method display1 and child class static method display2. All of you understood the code? So you understood the code anyway, but one small diagram I will. The diagram is nothing but I will show the object because in references concept, two classes are there means you created two objects and you linked it. But here, two classes, one object only. That is advantage of inheritance. So which one is high performance? Means inheritance will have high performance because instead of creating two objects, you can create a single object or not. Because of this reason, first I given references to you. If I give inheritance first, we will not concentrate on references, we feel it as a trainer. So first we show the references, interlinking objects, then linking classes. If we link a class, one object only will come. But wherever the possibility not available for interlinking classes, then we go with the references. In what situation you are going to use references, I only will reveal. But here, only one object is coming. I am going to show the diagram. So this is your first program here. Example program. I took project manager.
Demo inheritance. App inheritance number 2.
Somebody want to do some announcement to you. Okay. So project name I take it. Application. Inheritance one under P1. A dot H1 under P1. B dot H1 under P2. Demo inheritance 1 dot H1. This is one minus. So class A, class B, and demo inheritance 1. See there. Already you understood the concept already. The members are here available to be. A is parent, B is shape. We are creating an object for got the concept already. But even then, one small diagrammatical form showing that how the object is created. Execution flow of above program or application. First you must know the class files. How many class files available? How many class files available? So how many are there? 3 will be there. One is A dot class file, B dot class file, demo inheritance 1 dot class file. This is one. So see there, I'll draw like a JVM only, not like references. So this is the application. You are having application inheritance one, where three data files will come out after compilation. One is A dot class type. So B dot class type. Demo inheritance 1 dot class type. So this is bytecode. From this we are executing the main class. We are executing the main class. So generally we keep main class in the main class. So I am not drawing the main class in the down now. See there? Method area where classes are loaded. Method area where classes are loaded. Heap area where objects are created. Java stack area where methods are executed. Method area, heap area, Java stack area. So main class will be loaded main method will come for execution. Main class will be loaded. Main method will come for execution. So now, in the main class, the first line is scanner. So scanner object we are not driving. Some s is equal to 0 x2. Then we are creating object for b here. So b op equal to new and create. So create object for b. That's the meaning of it. Create object for b. Now your execution engine, your execution want to create the object for b. It activates the controllers. Check whether b is available here or not. b not available. When b is not available, they will ask class loader subsystem to load p, not a, to load p. Now the loaders in the process of loading p internally linked to a. Extends keyword is there now. So what happened now? The loader will load a. The loader will load a. Now a is having one variable. The a variable is instance variable. No memory is there. Yes or no memory. So a variable, no memory. Sir, b variable will get the memory. So b variable is a int variable and default value 0 current. Yes or no memory. The same way yesterday, scanner s is equal to null. Default value. If you don't write also, already like 0 coming down. Here one method is there, m1, instance method in memory not available in the class. Memory not available in the class. Then m2 got the memory. M2 got the memory. So void m2 got the memory. Now this class loading completed. So parent class loaded. After parent class loading completed, B got the memory and M2 got the memory. Once parent class loading has been completed, then the child is loaded. Then the child B is loaded. There is one link between these two. The link is extends. Now what is available in the B now? Sir, B one variable is there. Instance variable, no memory in the class. Not B, sorry. X is there. So X1 variable is there. No memory in the class. And Y will get the memory here because it is static. Y is equal to 0. And display one no memory in the class. So display one no memory in the class. Display 2 memory in the class. Void display 2 memory in the class. Once the loading has been completed, this is child. Parent loaded, child loaded. Now, these two are like a single component. Once the loading completed, they'll give the information to execution engine. Loading over. Now execution engine will look it whenever it looks there, it looks like a single component P only it looks. Understood this point? A and B according to execution the single component. So what it will do now? It starts creating object. Only one object because new keyword only one address. So only one object. So object creation starts. What is the rule now? While object creation, instance members has to get the memories. Now your execution engine looking at two classes as a single component. So example, today this class is running, that class is running. Two different classes. Management took the decision to remove this wall. So next day, Venkatesh, my professor, to go there. I came here and looked. Wall not there. Why a wall not there? I will not ask. I feel it as a one room only. That extended or not extended. But execution engine will say, I asked you to load B. Loaded, you loaded A and B. Why you loaded A and B means the extensive keyword is that you loaded. But whenever I look into B, B is looking like A and B. Both are combined and I can see one single component I can see. Now I am creating object for single component. Whenever I am creating object for single component, I will give the memory for A first. You will get the memory for A. A is the
Instance member of your parent. A will come.
first
Parent
parent
members will come.
First parent members. So A came, then M1 will come. Void M1 will get the memory. M1. After this one, child class members work. Child class means X. So X will get the memory. Then display 1 will get the memory. Void display will get the memory. So X got the memory. Display 1 got the memory. That is single object. How many objects created now? Only one object. The object belongs to child or parent or child. We must say child object only. Because new B, child object. The child object is holding the memory for parent components. Once the object creation has been completed, this address will be loaded onto. So only one object. Inheritance process for parent to child. How many objects created means only one object. If I want to access A, I can access OB.A. If I want to access X, OB.X. If I want to access B there, I can access with B.B I can access. Means through extensive keyword, static members are available to child. You can access. Then same if you want to access Y now, B down to Y. So remaining no need to draw. You understood the concept now? Here. In inheritance process, while object creation, parent class loaded onto method area first, then child class loaded. While object creation, parent class members will get the memory first, then child class members will get the memory. That is the behavior. So this is the diagram. Hope you understood. From that diagram, 2 points you observe. Okay. In inheritance process, while object creation, parent class is loaded onto method area first. Then child class is loaded. In inheritance process, while object creation, parent class is loaded into method area first, and then child class is loaded. While object parent class instance members will get the memory first, and then child class instance members will get the memory. While object creation, parent class instance members will get the memory first, and then child class instance members will get the memory. Right. Hope you got variables and methods. Now let us take constructors. Okay, right. Let us take the second one as a constructors. Constructors from the parent class or super class. If constructor is there, what happens? If constructor is there, what will happen? You know the constructor chapter now? Right. Constructor is a method having the same name as class and executed while object creation, because constructor call is available in object creation syntax attached with the new keyword. That's the rules. Okay, right. Now let us have one zero parameter constructor in the parent. Okay, right. First I'll write the program, observe it. Now let us take one more program. Application inheritance tool. Application inheritance tool. I am taking. Package P1 and package P2. Under P1, I'll take one class. Can I take say A? Just big name I'll take. In class I'll take. Under P1, I'll take C class. I'll take C class. end B class. Right? This is C class, child class, extends from parent class. I'm writing parent. Child class extends from parent class. Now look there. Sorry, in parent class, I am taking one construct. I am taking public parent class, one construction. Now system dot out print. Now parent class constructor I am running. Constructor means having the same name of the class. In the child class I am taking
one constructor. I am taking. Even constructor also you must write
public. Variables public, methods public, constructors also public. Logs, no access modifier. So here child class name. So we are displaying one message. Print one. So child class constructor. Child class constructor. So I took one constructor in the parent, I took one constructor in the child. Was it clear? Sorry, in inheritance process, we have to create an object for child. So demo inheritance too. We have to create object for child. Sorry, import P1 dot star Sir, we are creating object for child. Child class will be equal to new child class. Now while object creation for child, sir, this is child class constructor call. Yes or no? So parent class constructor call nothing. Constructor call means it is attached with a new keyword. So new keyword followed by child class constructor call is there. Parent class constructor call is not there. Okay, right? I will execute it. But here, parent class constructor also will come.
Okay, right. Now I called that execution engine from here.
Execution engine. Why you executed parent class? Because I called child class constructor. You must execute child class constructor only. Why you executed parent class constructor? I am asking that question to execution engine means I am the owner of the program. I am the code creator. Without my knowledge, how can you execute one parent class constructor? Then execution engine is saying that no, you got parent class constructor executed. Because execution engine cannot take a decision. I said, show me where is that parent class constructor called. Then execution engine says that here one super inside one super whether you added execution engine says I don't have rights to add that code. I will run it. So before execution engine, compiler will be. I call the compiler from here. Execution engine is saying that there is one super variable. Have you added? Compiler says yes, I only added super R. Then I asked the compiler, why you added? Then compiler is explaining a rule to me. In object-oriented programming, constructor is executed while object is created, and you are calling child class constructor. Then who will call parent class? Because parent class constructor will not be executed once the object creation is over. So if you are calling child class constructor, then who will call parent class constructor? Because of this reason, I interlinked parent class constructor by using super R. Understood this point or not? Then what is the coding rule now? When we have zero parameter constructor in the parent class, compiler at the compilation stage will add super R to the child class constructor. Compiler will add it. We are not adding because it has to interlink the constructor and run it. Once the object creation completed, parent class constructor will not run because it interlinks and run it. Make the statement. Now here, first case, zero parameter constructor from the parent class or super class, you can say. When we have zero parameter constructor, in parent class or super class, when we have zero parameter constructor in parent class or super class, then the compiler at compilation stage, when we have zero parameter constructor in the parent class, then the compiler at compilation stage will add super R to the child class constructor. When we have zero parameter constructor in parent class, then the compiler at compilation stage will add super R to the child class constructor. Underline that super and brace. All of understood this rule? Yeah, save the program. Same names will be there. So project name I take it. Application inheritance to P1 A dot Java not P class dot Java under P1 C class dot under P2 demo inheritance to dot Java the main class. So this super app we are not adding, compiler is adding. So I'll write the next program. Tomorrow I'll draw a small diagram on some super app. First time super app came, you'll get a clarity. Super app, this app, all will come slowly. Sorry, if it is a parameterized constructor, what happens? Okay. If it is zero parameter constructor, super app is added by the compiler. If it is a parameterized constructor, what happens? parameterized constructor from the parent class, or you can say super class. When we have parameterized constructor, in parent class or super class, then we must add super off. We only should add super off. If it is zero parameter, compiler will add. If it is a parameter, we add. We must add super off to the child class constructor to pass parameters. When we have parameterized constructor in parent class or super class, then we must, developer must add. Then we must add super off to the child class constructor to pass parameters. So we are going to add it. Zero parameter compiler will add. Parameterized because compiler cannot count how many parameters are. It cannot count because that algorithm. So we only should add super off. Wherever the super off is there, underline because in interview mandatory question. Super off. This combination is very powerful. Super will be there, super off will be there. This will be there, this off will be there. Definitely you will expect a question on it. They will not ask two combinations, they will ask. You must clearly explain them. Already this came, but more clearly you will show here. This off super. This one came. So remaining three will come tomorrow. So same program only. Same program. Application. Inheritance. Parent class, child class. Under parent class, you take one. Index, you take it. From parent class constructor, system.out.println to display that x, the value x plus x. Now the parameter must come here through child class. In child class, I will take int x and int y I will take. That x is sent to parent. That x is sent to parent and you display y here. One you can send it, one you can display it. So system.out the value y is equal to x. The meaning child class constructor took two parameters x and y. It is passing one parameter to parent class constructor, one parameter is displayed. Now go to the main class. You are calling which constructor now? Child class constructor. You pass 12 and 13. This is x, this is y. X you are going to parent, y you are coming out. Answer is coming or not? So supera, if it is zero parameter construction, supera is added by the compiler. If it is a parameter is considered, we are going to add it. Tomorrow I will give a clarity. Still progress because of time I typed it. Tomorrow with the diagram I will give a clarity. Have you understood this mind? So don't miss the class anyway. Not tomorrow. I don't know whether you will come or not. I don't know. But assignment I will write late. Last week almost 4 sessions missing. No? So I am moving the syllabus forward. So tomorrow I will run as usual regular class. Okay, right. Tomorrow's class is explaining supera more clearly with the diagram. Then I am bringing blocks. If I have a block with parent class, what happens? Right? After blocks completion, very small topic on the blocks. Then I am going to introduce overriding method overriding I'm going to introduce. After method of overriding, the time will be over. So Monday I will introduce overriding clearly and I will go with the overriding. After giving clarity on overriding on Monday, Tuesday the conclusion of inheritance and going overriding. When the intrafield started, then assignment starts. Until then assignment will not come. After Tuesday only assignment will be started on the inheritance. Very clear. So take a break. Thank you very much for today.